And I think we are live. Welcome, welcome everyone. Hello, hello. Oh, I gotta get live chat going. Gotta get that set up really quick. Let's see. I just did this. How do I do it again? Aha. We are up. Okay. Chat is live. Tesla Cybertruck, nice to see you. Welcome back. We are back here on our catting process. I've not had a lot of progress since the last stream. To fill you guys in, just in case you are new, welcome. You are watching me design a robot for a competition going up this Saturday. That is 5 days from now. I'm behind schedule. Although I'm always behind schedule when it comes to this stuff, to be completely honest with you. It's not something I'd like to be at, but I'm here now, so this is my reality, so I'm just going with it. As far as the actual robot design itself is going, I'm at a good spot, more or less. If you haven't seen it yet, this is Big Verta, my new 1 pound design, heavily inspired by robots like Nightmare. I wanted to build a Big Vert, but I didn't want to build a normal Big Vert, so Verta. Since my last stream, what I've done, you can see these little pockets here. These are my wire routing channels. You can see this little hole that goes from inside here out to here, and then to my actual drive motors, which are encased in these little wheel pod things. This is my drive motor wire routing that I have set up. It'll go through these holes, out to my speed controller back here. That's all good to go. The core of this robot I'm actually pretty happy with at this point. I just need to get the rest of the base set up and going. What that means for me is I need to start working on the nitty-gritty nuts and bolts, things like that. You'll see here, I just have most of these components basically jointed concentrically, meaning the circle matches up with the circle, the end, that's it, all good. Excuse me. There's no actual hardware holding any of this together, so I need to lock that in and see what I can do. That's going to be my main goal today. I basically need to get this robot finished today if I have any chance of actually competing on the competition on the 30th. Let's see. I think to get started, we're going to tie up and close off this back section here. That feels like a good place to get started with this build. I think the smartest thing to do would to just be building a back section here. I would want to make it a new component, but because I'm lazy and I just really want to get this build done, we're just going to build a component right into here as well. And we'll call it a day. This shouldn't be that hard, actually. I'm just going to steal this line, go straight up to here, and then extrude this section. Right. No, why would you do that? Project that. Now if I extrude, I can grab that piece. There we go. Bring it all the way to this side, create a new component out of it, call it a day. Boom, now the back section is covered up. I'll figure out the jointing between those two segments in a little bit. Now I just need to come up with a lid for this thing. I wanted to integrate it like the floorboard is. If you see here, let me hide this. The floorboard is actually flush. It goes down into the base. However, if you notice, I don't think I'll have enough room. I might actually, if I squish the battery all the way flat down like that, I might just have enough space. But I'm not going to worry about it too much. What I am going to do, show this back up again, I'm just going to put a lid on top. Basically draw a rectangle right here. And plop a rectangle right onto here after I grab this point. Just like that. And then I'll draw my rectangle right from here to right. I missed. To right over here. Just like that. And we'll call that good. From there, I'll take a simple extrude, grab here. Let's go up only... Let's do a 16th. I don't think that's really usually adequate when it comes to plastic ant weights. But we'll call that good for a top lid type piece. A pretty non-important structural component. At least non-important for the context of this build, at the very least. Okay. It's ugly compared to just doing a integrated flush lid, but we're at that crunch time now where I just kind of want to get this thing done. Also, in the interest of time, I got to figure out how to close off this section here. I think integrating it as a wall here is going to be the smartest option. So let's take this bottom section, which already has a file associated with it, and just drawing a wall section right here, 1.25 by that 1.25 inches, and extruding up by some number. Let's see. If I measure from the bottom here, from the top here, that's 1 inch exactly. That's convenient. So we'll extrude this value by 1 inch. Call it a day. And what the heck, I'll fillet this corner just to give it some structural rigidity like that. Back to assembly. Update. What do you mean? Just update. Come on. Did I do the wrong side? What is happening? I did do the wrong side. Okay, well, I will fix that now. Oh, wait a second. That just gave me an idea. Why not just integrate it? That's so much smarter. I should have thought of that forever ago. Okay, new plan. We're not... Instead of having this as a separate tiny little piece, we're just going to make it part of the main bottom. I don't know why I didn't think about that before. Let's get rid of that. Let's get rid of that. Let's get rid of that. All of those are no longer needed. Now here, we can add in the rest of the updates. Let's go back to this sketch here. We're going to add another rectangle. 0.125, 1.25, and again, we'll extrude that one by the same inch. Right here, grab it. Perfect. And we'll update the fillet, so we're also doing the other side as well. Okay. Now this back side needs that wall section, that little flanked piece, so we'll do just that now. From our assembly, we can see it is 1/2 inch apart. And the actual middle segment is 1/4 inch tall. So we will do the same. Let's see. Locked, good. And now we'll run the extrude and just spring all those out. Boom! That's a more cohesive base plate. Now I see what's going on here. That makes way more sense. Okay, look at that. Oh, I love it when things actually make sense now. Okay, cool. Base plates flush with everything else. I now have a dividing wall for that. The motor will need a hole on the side here so the weapon wires can go through it, so I'll draw that in right now. Let's say 0.125. 5.5, that's probably, let's do 3/8. It's probably enough space. And if not, oh well. It does look small actually. Why do you not? Okay, come on. That's definitely not gonna work. Okay, a little larger. 0.2 by 0.4. Okay, that feels a little better. We'll fill up this corner just a touch. Just to smooth the whole thing out a little bit more. Okay. I still don't think that's enough space, actually, now looking at it. I think it has to be the whole half-inch. And honestly, that's probably still not adequate, but we're just going to work with it and see where we go. Boom, okay. The bottom base section is now pretty complete. We still have our lid, which is there. The lid, actually now seeing it, should extend all the way to meet this top section here. So let's do just that. 1 inch away. Okay, cool. We'll just grab and project this across, make our lives easier. Just like that. And in a matter of no time, our build is starting to come to fruition. What did I click? That was corners out, yeah. Okay, that's... I'm pretty happy with the state of that lid now. Cool. Main chassis, main design, main everything is set. Now let's figure out how to actually hold the pieces together. I'm not gonna lie, I'm very tempted just to glue most of this robot together. Is that legal? Like, actually, is that legal? Hold on. I know this isn't the most up-to-date rule set. It doesn't say. I would assume, like, if it's in spirit of the rules that we're talking about, I don't think gluing the robot together is really breaking the spirit of the rules. It would be so convenient not to actually put any fasteners on this robot and just glue the whole thing together. And so I'm very tempted to do it. Actually, you know, I'm seeing now I might run into a problem when it comes to actually mounting the weapon motor in here. Because what I see... I might be able to finagle it in there. I'm worried if I just glue this whole thing together, I'd have no way to actually get this weapon motor in here without breaking something. Okay, I might try to just figure out a mounting solution for it. A plastite screw is how big from McMaster? Let's find out. Because I have a whole pile of plastites still, number 4 plastite specifically, that I use for pretty much all my builds. I just don't know the diameter of a plastite off the top of my head. But I feel confident these things would work. It's a 3/8, but it doesn't really matter. Rounded, I guess it doesn't really matter. I just need to... All I care about is the OD, the outside diameter. 0.112. Okay, that is totally viable then. What we're going to do, we're going to add some screw holes on the bottom here. Let's go right here, put a whole circle. Let's say 0.1. Actually, let's do Let's really go for it. 0.095. Actually, what hole does it recommend? 0.086. That's what I'll do. 0.08. So let's go 88. I don't know, just round up. Why not? Because when you print from the angle that I'm going to print at, no, should I print? I was going to say, when it actually comes to 3D printing this piece, I was thinking about printing in this orientation. However, that leads to a lot of vertical layer weakness. The proper way would be to print it in this orientation. So all the layers, once the part's completed, run up, down, which should give you more strength. And in that case, you do get more accuracy with the hole size, meaning 0.086 is the final number we're going to work with today. Now that our hole's set, we are going to pattern it, bring it across here. We played the game of, is there such a thing as too many screws? Yeah, yes, there is such a thing as too many screws. We're going to say 5 is the right number. 4.5 inches, maybe? I think that's fine. Yeah, I'm okay with that. Save. Oh, wait, I gotta actually extrude the holes first. In. Okay. Let's go 3/8. Because if I remember correctly, I have 3/8 screws. So minus the actual material that it's holding up against, which I think is 1/4. Yeah, minus the 1/4, so that's only 1/8 of engagement, actually. I should probably... The holes here need to be countersunk or something to make that fit better. Regardless, that looks to be good. We're just going to project that onto the other side and see how that looks. Project. Grab the... Hello, Blaine. Nice to see you. There, and we'll move these also 3/8 in. Okay, now our bottom mounting holes have been complete. I actually think in hindsight we should put a hole here just to add a little bit more reinforcement. Where exactly here is kind of variable. Let's just call it in the middle. I think that's a good spot. That's not the number I wanted at all. 0.1. There we go. Had to think about that one. Alright. And that one's going to live with the other extrude. There we go. Rinse and repeat on the other side. Okay. Those are going to be all the primary mounting holes for Verta. Now we just got to update that onto the main rails as well. Perfect. Now, we take a leg, or we take a mounts rather. We hit edit in place, capture position, and now we will project. There we go. Ah, problem. I see there's a clearance issue here. Okay, no worries. We will get rid of that and worry about that later. For now, we'll just grab these holes here. Actually, these holes should be larger to accommodate the size of the screw. A number 4 plastite is a diameter of 0.112. So let's do 0.12. Let's just call it we'll round up, call it an 8. 0.125. And then once these are all in, those will be our clearance holes for the plastites. What is the texture on the wheels? That is a very good question. When I catted these wheels up, I needed a good way to model the weight. And there really wasn't too many good options. So I chose I don't even... Some flavor of rubber, I think. I'm not entirely... I think it's actually fabric in hindsight, because it was the closest thing in mass that Fusion had to the foam of normal fingertech wheels. Finish. Okay. I broke some things in my sketch, but that's not a problem. Let's find out what this material is. Let's see. Wheel. Properties. Yeah, they're currently made out of fabric. It was the closest thing I could get to actually get me the roughly similar weight of a fingertech foam. It's not the prettiest. Gets the job done, which is why it's there. Okay, cool. Screw holes are in. So mounting for the bottom section's done. Let's do the same thing on the other side. Oh, yeah. Wait, I see a dilemma. Well, if that's the case, that basically means I have two trains of thoughts with this design. Option A, I can delete this rail entirely and just make a new, basically identical version of it. Option B, I make the top lid bolt on the same way the bottom lid's bolted on. And now that I say that out loud, I don't like that idea, just because I don't want to have to deal... I don't want to have to deal with taking out 10 screws on the sides just to remove my top panel. That means I'm going to have to make a new left side rail. Alright, let's get to work then on that. Delete. Okay, and we'll just delete the rail altogether. Break link. And goodbye. Okay. So, new revision. Drive, or weapon mount. Is this the left or right? This is the right of the robot. And so we'll copy this into weapon mount left. Okay. New weapon mount is made. Rename. I dub the left. Oh, we gotta get rid of this. This is gonna be distracting. Goodbye. What do you mean can't? Okay. I guess you'll stay. One of the benefits of making it a bespoke part is that I can do certain things to it. Like, these wheels are completely useless on this other side, so we're just going to not have them. Just like that. Oh, is that all that extrude is? Oh, let's get rid of it then. And now it's a stronger part as a result. Also, what I need to do, this circle here, it should be the diameter of a bushing that I ordered. However, I don't remember the bushing. So we're going to look it up really quick. Yeah, if I can type. Order history. These bearings right here. I already have a few of these bearings already, so I know these are the ones I'm going to use. 8 millimeters. Why did I choose metric? No. Okay. Metric is the world I live in. 8 millimeters. Let's do a little larger, because I know printers, especially my printers, aren't great. 8.5 millimeters to be safe. I am back, Caleb. Hello, hello. Boom. Okay. Now that should be accepting of the bushing. In fact, let's download the CAD of this one and import it into Fusion as well. Okay, save, call it good. Go back to our assembly. And we will throw it in. Okay. I think the smartest thing would be to join here. Yeah, I think that's fine. I'm okay with this. Hey guys, welcome. Just joined the stream and I like it. Aw, thank you. And yes, this is a bot 4 battle. This is a 1 pound plastic antweight known as Big Verta. Work in progress, of course, but the goal is to get this thing ready for a competition on Saturday. Okay, I like that a lot better already. Let's see. Now let's try to add in that bushing that I found from McMaster. Downloads. Did I not download it? Yeah, it's downloaded. File. Open. Oh, there it is. I just had the folder wrong. Save. Throw it in. Cool. Oh, I already had a different pushing. That's funny. This is the one we are using now, I guess. That is correct. I am admittedly a little behind the curve on this one, Caleb. The robot needs to be done today so I can print tonight to build tomorrow and get done for Saturday. In other words, I have plenty of time. Okay. Bushing's in. That looks fine. Let's mount our arm back on. I think it's that one is the center. I guess we'll find out. Yeah, that's center. Yeah, okay. Open it up. There we go. Verta is coming back. What do you mean I ain't making it? That is the most lack of faith statement I've ever heard in my life. I'm totally making it. I think the blade's hitting the ground. Okay, well, that's fixable. Not making it. I'm definitely making it here. Is it hitting the ground? I think it's hitting the ground. I think it's hitting the ground just enough that I'm worried. Frankly, I'd rather not redesign most of this chassis again, so I think instead of fixing the chassis to make it fit, I'm just going to shrink the weapon slightly so it doesn't scrape the ground. Or I might just print multiple versions of the weapon just in case. Let's see. Let's make... I like the look of my drive legs right now. Like, I kind of like that weird circle aesthetic. What would be nice is if there was almost a flange to mount screw holes into. Actually, before I do that, I'm getting ahead of myself. Let's just put the mounting holes for the screws first. Because before any of that matters, screw holes need to be added. Project. Hide. Grab. Okay. I will say, I'm normally behind when it comes to my robot builds. This is a consistent theme with every single robot that I've ever built for a competition. I am further behind than I typically am, usually. I'm usually still catting, even up to like a couple days before the event. But usually the cat is more complete until then. Spare Goomba? Trust me, good news for you, this robot's not the one who's going to be fighting Goomba. You have gotten off because this is plastic ant weights instead of the full combinance. So your robot is spared. Could I sand down both sides of the spinner? I could. I think I'm just gonna change the tooth geometry just a little bit to compensate for it. Because if it's close enough where sanding would fix the problem, I'd rather just take it off. There, yeah, I gotta draw, you know, I have to draw a ground plane. I keep guessing. This line is weird. I deserve more subscribers. Thank you so much. That's really nice of you. Edit. That's the problem. This should be here. Okay. So that's ground, right? That blue line represents ground plane. And so if the blade touches it, that's bad, right? Oh, wait, look at that. We are clear. We are in the free. You see that? No contact being made. As close as it is. That's only a little sketch, but it clears. Look at that. It's beautiful. Okay. We'll hide that now. Okay. That's set, that's set, that's set. I have screw holes down here. I got to add in mounting for my top lid now. Okay, I gotta mount the top lid. I gotta mount screws to the side to hold my wheel pods on. And then, might need more breathing room. I like living on the edge, so we're gonna run it. Yeah, okay, I need to mount the wheel pods, the lid, and then I think, honestly, this is pretty good for the robots. I'm pretty satisfied with that. I think I'm ready to start printing pretty soon. Yeah, let's go for it. Let's start with the wheel pods. What I was saying earlier, what I'm going to try to do, I'm going to take one of these wheel pods and add a flange onto this outer edge. That flange will hopefully be where I add these mounting screws for the actual robots. So we'll start off with a circle. It should be the size of this circle, so that would be 1.6. That is such a arbitrary circle diameter. Why did I choose that? 1.601? I hate that number. What? I don't know where that came from. Okay. I guess we're, that actually kind of upsets me. I don't know where in the design trend I ended up choosing that number. We'll just call it 1.6 and call it a day. What size battery am I planning? I am running... Currently what's in there is a 450 4S. It's probably going to go down to a 3S by the time it actually enters a competition. I think it's just because I have 3Ss on hand. It's really whatever battery that can fit in the robots come competition day. But right now I have a 450 in there, just because it's the biggest battery that I probably would run. And so I've covered my bases. How am I going to do this? Because I want to do this without messing up that flange there, without messing up the wire routing. And as always, if you guys have any ideas, suggestions, things you want to see tried, let me know and we can try to integrate this as well. Let's see, let's take... Okay, I think by leaving that section out, I don't really like this look, to be honest with you. I don't know. I'm kind of... I'm both lukewarm on the look, and I'm not too sure if I can get a good mounting on there. It feels kind of fragile. Maybe if I made it to 0.2, it'd be better. Save. And put it over here. Let's see how it looks. Why is it clipping now? Edit joint. Let's take... Is that a good look? I'm not too sure. Have I heard of the hit game Garden of Banban? Bonbon? I can't say that I have, Kenzie. Please tell me about it, actually. But no, I actually have not. Now seeing it, I really should close off this circle entirely to help the wire routing be a little bit cleaner. Also, I can tell my circle was not concentric based on that joint. That was a fail. Let's redo that. Let's see, remove and rejoint. I think that's the joint that I need to mate to. That was the correct reference. Are you not gonna... Why would you not snap the flush? Oh no, Cormac, what are you doing? Well, welcome to whatever this is. You get to join me in the nightmare of preparing for Saturday. Can you add an M2 flamethrower to the bot? Technically, yes. Practically, no. For many reasons, actually. Not just logistic ones. Ethical ones, to be honest. How does that... Oh, that's not what I wanted. Let's take this... Go here. And we'll cut that piece. Is that better? I think so. Because it still gives me my pathway for the wires to run into there. I still have my channel for the wire. And then I just have a little bit more meat around here to add structure to the build. Let's see how that looks in assembly. What is stopping you? I lack experience, technique, skill, and I value my fingers and body hair too much to embark on that journey. That has not stopped other people. Let this be a lesson. That has not stopped other people from incorporating fire into the robots. It doesn't mean it is an impossible idea. It's just if you want fire, the entire robot becomes fire. It becomes the identity of the robot. Fire can't just be an afterthought. It has to be the robot concept from the start. So that is not the vision of this build right now. The vision is Big Dumb Spinner, and I think actually I'm starting to realize it with this mounting system here on the sides. Okay. I think I'm happy with that little extra bulge there on the side. And if we go to a front profile, let's hide some of this mess. If we go to a front profile, I think that little bit of extra plastic there does help stretch out the wheelbase a little bit further, helping me with the tipping motion just enough, I think. So we're going to keep that set up, and then add some mounting holes onto the drive like now. Let's go here. This is going to be actually a really interesting idea, because what I want to do is I'm basically trying to add three circles, or three drilling holes And they all need to be equally spaced. There's a couple ways I'm going to do this. But first, it starts off with a line. Let's go here. 0.625? Now let's do a little more. 0.7. 6875. I think that's fine. Let's see. We'll put a plastite hole in, which is 0.125, as we previously disclosed. That's honestly pretty far. Let's go a little bit further in, 0.65. Let's do 625. I think that's a good compromise. Yeah, we'll live with that. Okay. From there, let's run pattern. Grab point. Just like that. Now we have 3 perfectly spaced holes for us to run our extrude with. Just like that. Run them through, and just like that, our mounting system is, it's actually almost complete, because I just remember the screw heads are larger, so they're going to eat up more space. Let's add in some oversized holes here, just to give us a little bit of clearance. And we have the space, so yeah, that's fine. Save that. Okay. Now with that set, we have, ooh, okay. Let me hide these sketches here, because they're killing the vibe, killing the aesthetic. And this robot is nothing without its aesthetic. Oh, wait, that looks pretty. I am happy with this. Okay. So those will serve as the mounting holes for the Verta wheel mount. They actually could be more robustly built, I think. 3 screws, honestly, isn't that much. However, I have a sneaking suspicion that what's going to fail isn't this mounting part, right? I don't think these 3 screw holes are what's going to be the break. I think more likely this whole part's going to break first, and then after it's been beat up a few times, then this part will fall off. But this won't be the failure point, which is what I worried about. So I think we're set there. I'm really happy with how that looks. So let's do the same thing on the other side now. And I know there's probably a more efficient way to have done this simultaneously. Are you able to add it into Mark II grenade from World War II to the Battlebot? We are going to say no on that one. Again, for a variety of reasons. The biggest one is that I believe it's expressly illegal for civilians to have explosives of that lethality level, just, out and about. So even if it were legal, I don't think sourcing it would be the easiest thing in the world. The legs will snap in half. You say that like it's an inevitability, Caleb. You act like it's already happened, which it has not. There's still, you have not seen what this robot is capable of just yet. And that they probably will snap in half, and you're exactly completely right. But you don't know for sure. Okay. That was not what I wanted at all. What happened? Okay. Just travel back in time. Man, you know what? If we'd had robot combat back in the days of 1945, we would have had so much more creative and fun ideas. I will admit that. I will say I do think robot combat kind of peaked somewhere around the early 2000s, because back then with robot combat it was so much more redneck, for lack of a better term. It was just a bunch of people who didn't really know what they were doing, so you just saw them try every single idea up on the wall. And it led to the coolest, funniest, and best designs. This was where creativity was at an all-time high. It was amazing. Nowadays, robot combat has become much more It's kind of like NASCAR F1, where everything's so meticulous, so planned out, and it's so choreographed, where it's harder to innovate. The innovations come in much smaller ways than before. Can I add some bunny ears? I With how my robot's designed, it's definitely not bunny ear capable. Ban canned soup. Why would I do that? It's gonna destroy my bots. And you know what? All of robot combat is living to see your robot get destroyed. So, if you come out and destroy my robots, I would love to see you try. Frankly, that is why we do this, to see people try to destroy robots. If you're not trying to break each other's toys, what's even the point? Canned soup is there. Oh god, is that like a creepypasta now? If I say canned soup 3 times in the mirror, will they come up behind me and attack? Let's see. Extrude should go all the way through, just like that. And then let's add in those big flange holes that we were talking about earlier. And there had to be a more efficient way to do this. There should have been a way to do this where I basically do this whole process once and it worked for both sides instead of having to recreate the exact same feature for both wheel pods. And now that I think about it, I think I can visualize how that should have happened. But I'm already there. Breaking the kids that have the toys. Your next one should be an M1 Abrams. You know what? I thought about that. Genuinely, I've had this idea for a while of a turret spitter type robot. Basically, it's a tank treaded robot with a big rotating turret on top. And that rotating turret was basically an overhead spinner. There's old school robots called Battlebot, and there's one that straight up just looked like a tank with a mace on its cannon head. Man, it fought in Robot Wars. I can't remember its name anymore. Anyway, those are objectively bad designs. They're not really practical for a lot of reasons in modern robot combats, but they're cool, which is why I still kind of like and value them. Anyway, let's see. I'm pretty happy. I would never destroy a robot. Cheese Cat's a sorcerer. Let's put some screws in here and see how it looks with some hardware. Reject robotics. That's not where I'm going. I have a folder for this. Robot parts. There we are. Hardware. Nuts and bolts. Number 4. Okay, I have 3/8 plastites. Let's see if they fit. Oh, that was too far that way. Okay, I'm pretty sure a 3/8 M4 is just a little too short. I definitely should thin up some of my walls to make this fit better. Like that. Because I'm getting enough threat engagement, I think. Like, it bites just enough, it looks like. And I don't know if I'd rather sacrifice the strength of the part by making it thinner just to increase my threat depth. I don't think it's a worthwhile trade. Speaking of tedious things with fusion, adding screws, adding hardware is the most tedious thing because you're literally just jointing them in one at a time, and it is so laborious and it's so dumb. Anyway. How do you feel knowing a guinea pig gamer isn't joining the stream? Who is the guinea pig gamer? Out of sheer curiosity, like, I have so many questions as to who that could be, but I don't have a full intuitive knowledge of this one. Coolness better than good idea. I 100% agree. Example, all of my robot concepts. My robot concepts live and die on that motto. Could I add another hole? Like a 4-hole system? I could. The issue that I was... the reason I did 3-hole originally was just because of this rail right here, right? Because of the actual leg. If I did 4-hole, I think I would end up cutting into my actual uprights. A certain 5'2". There's that narrows it down to like Tucker. Okay, it is just Tucker with glasses. Okay. I was like, there's not that many people it could be, but there's still a couple options there. Okay. But yeah, no, I think a 4th hole would be nice, but that rail here kind of gets in the way, which is why I'm not going to add it and leave it at 3. And now that I have it mounted, it actually doesn't look that bad. It is very bulky of a wheel pod, but I think it adds to the cool factor, to be completely honest with you. I like how that looks. Yeah, I'm right. Alright, Caleb, you did not make it hard necessarily. You really narrowed it down from there. 5'2" with glasses. That really leaves the box to like one other person. Or no, 0 other people. It is just Tucker, I think. Since we're here, might as well put the rest of the screws in. Okay. We've really hit the more tedious parts of robot building, where it's just, that's a bolt, that's another bolt, that's another bolt. He said my bot's not cool. Well, what does he know about cool robots anyway, huh? Who needs chicken defrosted? Who is not doing their chicken defrosting duties? Yeah, that's cool. I'm okay with this aesthetic. Honestly, it might be worth recessing, adding a little bit of a countersink. That might be if I'm less lazy type person. I might do that. That's not that much work. That does invalidate all this work here, whatever. We'll just do it. First we're gonna save this. Will there be a build session tomorrow for the 15? Yes, there will be. If you are relevant to any students part of the 15-pound build club for the upcoming Sacramento Pop Battles, if you are able to attend, we will be doing a build session tomorrow morning before class starts. This build session will run from about 8 a.m., 8 to 8:30 a.m., all the way up into class starting at 10. If you're able to make it, please do show up. We will try to get this build going as soon as possible. We're making good progress, guys. We just gotta get over the finish line. Okay. Anyway, let's keep going. All these holes here, we should probably add a tiny countersink in. Let's do 0.25 for all of them. I think 0.05 is enough of a mild flush. Something like that. I think that's enough to give me a little bit more thread and flush my screws just a touch. Break all the joints, do it. Oh, it was on the other side, cool. I should probably just fix the other one while I'm here. Okay, let's do the same deal. Circle, and then add all the circles down at the bottom. Okay. 0.25, 0.25, and 0.25. Extrude. .05. Yeah, let's call that good. Come on. The goal for today is to get this build fully catted, so I can actually get this thing printed. There it is. I had a feeling all my joints break. Let's see. No, just snap concentric. There we go. Oh, that's way better. Much flush. I don't think the sides will like being printed with the holes being that close to the bottom. I agree. You can tell it's a little messy there. I'm not too worried because it's going to be printed in this orientation, right? This is going to be how it's going to be printed. So I get a lot of detail here, and if I lose plastic here, I'm not really too worried for that. I think that's a worthwhile compromise to actually get the screw flush with the design. I think it's worth it in my opinion. But that is a good point. Okay, that one snapped right away. Okay, perfect. Okay, that looks good. I'm happy with this. Yes, I have very bad printer scale-up. Thank you for noticing. I've had good luck with PLA Pro. The PLA Pro has been the better of my plastics to work with, and this entire robot's going to be PLA Pro. So hopefully I won't run into any of those errors when it comes to this build. But of course, fingers crossed, because my god, I got some bad printers. Okay, top lid's on. Man, I think I just put some holes on here and I call it a day. To answer some lingering questions that I know you guys have, how does it self-right? I am entirely going to rely on the weapon for that. Whether or not the weapon gets me back on my wheels will be a mystery that even I won't know until competition day. But that is the self-righting plan. As far as everything else that goes inside of it, I'm running a either 3 or 4S LiPo to be determined based on my availability, a Belenki Nano, as well as a random 30 amp brushless ESC that I have. And that's really it for guts. It's not too fancy or complicated of a build. Have I heard of Half-Life? I mean, hasn't everyone heard of Half-Life? No, I've actually never played Half-Life, but I hear so many great things about that game. Game of the year, game of all time, stuff like that. So I've heard a lot of pros about that game. Let's see. Let's hide that. Extrude those. Perfect. BRB, I'm going to use the bathroom. I'll be right back. Okay. I am back. I feel like you should play it, and I think you'd really like it. Is currently eating everything I own. Make them flush. I think that would look more aggressive. Make what flush? What piece are you talking about here? Are you talking about the screw heads flush or something else? He was at my computer. The creepypastas are really out of this world here right now. This is Bloody Mary 2.0. So, okay, if I take the screw heads and flush them up, I mean, they're actually sticking out slightly. They protrude slight. I'm honestly not quite following where you're going with this. Are you saying this hole here flush with the diameter of the screw head? Or am I misinterpreting that? Let's do 4. Okay, so bring that down. Alright, I think I'm going to add in those remaining screw holes here, and to be honest, that just might be where I call it for this build. I think the last step will just be printing. Actually, I think I'm going to just update it from the weapon mount side of things. It might be easier. And I remember the measurements, so... I don't remember the plastite holes, though. Order history. That's not the wrong part. Plastites. .086. Put the head of the screw on the surface instead of embedded. It was on the surface already. That was the original design I had. I felt like I wasn't getting enough engagement. I'll show you what I mean in a second. But the issue what it looked like to me, was just that it wasn't getting as much engagement as I would have preferred. Generally, I'm of the mindset that you don't need too much engagement anyway. But when everything is made out of plastic, I worry about it just a touch more. And as soon as I finish this one up, I'll show you what I mean by that. Stop, where are you? Oh my, this is annoying me now. Okay, 3.5, 4. What is happening right now? I just want to pattern you, and I want to go this way. Okay. 4. I want to do it by 3.5 inches. Why was that so hard? Okay. We'll take all these. We'll go down by our 3/8. Okay. That right there is a finalized weapon rail, I think. That part is complete. Let's do the same thing for the other side. Same deal, 1/8 inch up, 0.09, pattern, okay. Okay. Done. Update. Oh, what did I break? I have to roll back designs. Oh no, I messed up. Dang it, okay. I forgot to save the weapon mounts beforehand. That's so annoying. Can I pull this to the latest ref? Okay. Finish. Okay, that one I fixed. Let's try to fix the other one. If you've never used Fusion before, it has some weird associations when it comes to part contexts. As you're seeing right now, it's one of the things that if you've only grown up using things like Onshape or SolidWorks, it doesn't quite have those same issues. But it's just one of the many quirks of using Fusion. Okay, I think I fixed it. Okay, cool, it's taken care of. Problem solved, crisis averted. Okay. That will be the build. I think we are ready to go. We are ready to send it off for printing. After a lot of trial and error, Verta has finally been realized. I'm going to just add in some of the hardware right now before we call it a day. Maybe we'll get a render together for tonight. Why not? Get ourselves a pretty little photo op with Verta before we actually call it a stream. Thank you guys. Thank you for sticking around during this process. If anyone in chat knows of a faster way to install screws into a robot, please let me know, because this is almost as time-consuming as installing real screws into a robot. I am fully open to suggestions. You know what? I realized there are some small things I need to add on here first. I don't have a weapon lock location just yet. That needs to get added. No, I want the pain. I don't think want is the correct term for this, Caleb. I will begrudgingly suffer through the pain if it means I get a cool robot at the end of it. What is Ireland like, Can Soup? Never been. Let's do that. Okay. Yeah, there. Okay. We are almost halfway through all the screws. Let's do this. Samsung Smart Fridge is the best way to watch any content. So I fully respect your choices there. 100% in favor of this move. Fully approve. My life with 15. Because okay, here's the thing. I cannot believe, or I do not believe, that professional engineers are mounting screws inside their CAD models the same way that you and I are mounting screws in our CAD models. I want to believe that there is a smarter, better way to install hardware. I just don't know what it is. Dysfunctional human, hello, hello. You got live chat, finally. Well, what was the holdup there? What took so long? But thank you for joining. I'm happy you could have made it. Okay, I got like 5 more screws to go. 8 more, including the other side pod. Okay, you say that they don't. I will tell you, at my last job, when we were working with our mechanical engineers, they absolutely did not put screws or hardware or anything like that, and they trusted all fit. But, however, there's so many examples of models just online where people, whether it's we're talking about like things made by Ford, NASA, F1, whatever, well done full CAD models of just fully assembled pieces, including hardware, including all that stuff. Maybe they're just like paying like a low wage CAD draftsman to add screws. Maybe that's what's happening. All the engineers are busy designing the important bits while the draftsmen are just adding screws for 8 hours a day. Later joiners, what? the devices that you are watching on, man, humanity's truly evolved as a society. We're watching it on everything from toasters to fridges. And fighter jets, man. Let's see. There we go. Oh my gosh, 3 more screws and we're done here. Or actually not done, because there's one more thing I wanted to add. Such a specific model number, Canned Soup. Okay. One more, come on. 7:30 is when the stream started. We won't go until, we'll probably be done around 9 today. Maybe a little sooner, we'll see. Okay, all the screws have finally been added. The one thing that I've been needing to add onto this robot is a spot for the weapon safety lock, because I want to, you know, not be disqualified from competition. That'd be really cool. The way I'm going to do it is just by adding a little bunny ear to the side here, somewhere in this section. And I'm going to make it big enough to accommodate like a 1/4-inch dowel or something along those lines. Nothing crazy, nothing complex. Just a little circle that goes out. Let's say 45 degrees, 0.5, 1/4-inch dowel. Let's change it from 0.5 to 3/8. Yeah, I'm okay with that. And we'll concentric it up. Let's see. I want midpoint. What is midpoint? There it is. Tangent it up. I put all my screws into a pile, clipping them so I can pull it from a pile instead of one by one. It's kind of clever. What is this for? This is a 1-pound combat robot for a upcoming robot event on this Saturday, actually. Most builders are usually more put to... Why did that do that? No. Join. Most builders are usually more put together than this, but I'm here, so this is the state of it. Will there be more content? Absolutely. The goal, by the way, is to do this regularly on Mondays. Mondays is probably going to be my streaming day, in all likelihood. There we go. There's one bunny ear, and you can see how it's designed, right? I basically take a rod, a screwdriver, a dowel, whatever. I poke it through that hole, and it basically stops the blade from being able to rotate, so the weapon is effectively locked in place. I'm going to do the exact same thing for the other uprights, and then I think we are done here. And instead of doing exactly that same process again, I'm just going to project it because I am lazy. Just like that. My walls. Are you responsible for the knocking that I hear? Why do you keep adding a new body? Just join the thingy. Okay. Perfect. Okay. Save. Boom. And just like that, Big Verta has finally been realized. Let's put this into a render and see how it looks. Let's close the gallery out. What's the... I feel like there's a good angle I can get this robot at. I gotta pose it a little bit. I wonder the rear angle like that, maybe? If I get the blade, like, right here. A 5.8 rotary. I don't believe that is a real engine. I don't think Mazda made a 5.8 rotary in their day. Or any day, to be honest with you. Let's try... Man, I really don't know what a good angle is for my shot here to capture. Extend the weapon lock to be a bunny ear. You know, it kind of is a bunny ear. Should I go all the way with it? There's not really a benefit since the wheel doesn't hit the ground. Like, there's... As a bunny ear, it really doesn't do much for me. It's equally useless, kind of no matter what. I think what's going to happen more likely is that if it falls over and tips, it's going to tip over something like this, where it's going to fall face first on that edge. That's probably about to be what happens. Alright, back to posing. Let's try that as the shots. We'll render and see how it looks. No Mazda. I'm sorry. We'll make the Miata CAD sometime in the future. But today is not going to be that day. My back is starting to hurt. Alright. Mic a little bit higher. As this render is chugging along, I can... Ooh, okay. Now that the graphics are really starting to render on this thing, I think I like the vision now. I like how this thing looks. How do I feel about the 1990 Miata? I'm a Miata nerd. I think Miatas are awesome. I'm probably going to pick up a Miata at some point. I feel like any car person needs to have a Miata at some point in their life just because it is that cool project car. And so I think Miatas are awesome. I think every year Miatas are awesome. 90 in particular, solid year. There's nothing about it that's too amazingly different from the years before or after. I just think 90 is a good year. Okay, that's a pretty good render. Let's let my computer work a little bit harder to render another version, because I think I can get an even higher quality one if I let my computer chug on it. Or not. Render, please. Did my computer just give up rendering? Oh yeah, that's what I have to do. Okay. Anyway, we'll let it keep going. It'd be really cool to add some kind of like decal, like big vert along this back edge here. I think that's something I'll do in the future for like later revs. Definitely not this iteration though. I missed a screw. Oh my gosh, I forgot one. Oh, that's so annoying. If I add the screw now, I have to redo the entire render. It's not worth it. The render's pretty good in some areas, like here. Areas like right here, it's still really fuzzy. My computer is not happy with this with these sections, the shadows. It's chugging to try to render the graphics for this one. Can I eat a lemon live on stream? You know what? Well, let's make that like a sub goal or something. If we get to that point, we'll try to set up sub goals later down the road. Then we can do some other stuff. Cooking live stream. I have a cooking Instagram if you want to follow it. Do you even food bro? If you don't care about robots and want to see me do something else. Is the stream is not 10 minutes in the past. There's no way it is that delayed. Dang, the stream's that intense, huh? Alright, this render is just about complete. So, oh, there it is. That is Verta finalized. We'll capture that image. Okay. Save to my computer. And let's open it and see how it looks. Do not use paints, please. The lag might be subsided at this point. The lag should be over it by now. I think the lag should be taken care of, hopefully. Fingers crossed. Okay. But that is Verta complete. I'm going to start printing, get this squared away, and I think we're done here. I think that's it. So, thank you guys for watching. I am sorry for the lagginess that happened over there. Next time you see me, this robot should be competed, or should have been built, competed, and hopefully won a fight. So, thank you. Thank you for watching the stream. I hope you enjoyed it. I'll be back here next Monday, probably doing more of this, maybe something else, we will see. Anyways, thank you guys. Please consider checking out my sponsor, W.GG. Use Reject Robotics to save 10% off your next order. Thank you guys for watching, and I will see you in the next one. Take care.